Well, we are getting ready to go on this part two of the two-part video on graphing quadratic functions. This part two is actually on the graphing part. Remember, part one was on the introduction and definitions and just kind of identifying different parts of a quadratic function. There are 5 steps to graph a quadratic function. Um, I believe if you do this, if you graph enough quadratic functions, you will just remember those 5 steps in your head. Step number 2 is the only thing that I'm asking you to really memorize. The rest of it you can keep in your notes, and you can, check back to your notes to and refer to that. But step number 2 there, to find the x value of the vertex, I want you to get that memorized, that formula, x equals negative b over 2a. That's a concept that we will use every single problem. So, and I don't think I have it written on any of the other pages. So you need to have that memorized. You might want to keep these notes handy, these steps. That way we can come back and refer to these as you are as you're working these out. I think we have a few examples here today that'll show you a different type of variety of quadratic functions that you could be graphing. So when you're done with this video, you should have a good grasp on how to graph quadratic functions. All right, if you need more time to write these down, go ahead and do that. Go ahead and pause the video and do that. I'm going to move on to the first example and get started. So whenever you're done, you can hit the play button and watch that. I may refer back to this during the first example, but you should always keep these handy. That way you can pay attention to what steps we're following. Okay, so let's look here. It says graph the quadratic function y equals, in the upper left-hand corner, y equals x squared minus 4x plus 3. X squared minus 4x plus 3. And remember, you were supposed to have the standard form of a quadratic memorized. Y equals ax squared plus bx plus c. What number is above a? That would be the 1, the invisible 1. What number is above b? You might be thinking 4, but you have to pay attention to the sign. That's going to be negative 4. And what number is above c? That'll be 3. Okay, so if we look here, we have A, B, and C identified. We're getting ready to go. It says create a table with at least 5 ordered pairs. I have that table created right here, 5 ordered pairs. Your table can either look like that, or it can look like X and Y, where you put your 5 ordered pairs like this. Either one's fine. I think for the examples that we work with today, I think they all are vertical tables like I have on this one. So we have a table created. Step number 2, I believe, says find the x value of the vertex. Find the x value of the vertex. Well, what am I going to do with all my work? I have this graph here. I'm going to graph a point in a moment, or I'm going to graph the parabola in a moment. But I want to go ahead and do the work on a different slide for you without the graph. So we're going to find the vertex here. Find the vertex. We're going to find the x value of the vertex because it says x is equal to negative b. So what's b? It's negative 4. Over top of 2a. And what's a? 1. That's going to be the vertex formula. I told you to have that memorized. I know it's problem number 1. You may not have it memorized, but make sure you are getting that memorized after today. So this negative sign right here, it only goes with one of those numbers. It either goes with the top or it goes with the bottom. I'm going to put it with the top, and so a negative 4 makes a positive 4, and on the bottom 2 times 1 is 2, so, and we have 4 divided by 2 is 2. So the x value of the vertex is going to be 2. The x value of the vertex is going to be 2. And we notice this says x is equal to 2. That should be the equation for your axis of symmetry. X is equal to 2. It's a vertical line that's going to pass through the x-axis at positive 2. Step number 3. Substitute the x value of the vertex into the given quadratic function to find the y value of the vertex. What does that mean? Substitute the x value of the vertex into the quadratic function to find the y value. So that's what we're going to do. Y is equal to x squared, but what's x going to be? X is 2. So x squared minus 4 times x, remember x is 2, and then we say plus 3. So we work this out. 2 squared is 4. Negative 4 times 2 is going to be negative 8, and we have a positive 3 there. 4 minus 8 is negative 4 plus 3, and negative 4 plus 3 is negative 1. So now we want to put the vertex into the vertex will go into the table, and it goes into the middle part of the table. The vertex goes into the middle because on a parabola, the vertex is in the middle. And the line I just drew in there was your axis of symmetry. So x was 2, y is negative 1. X is 2, y is negative 1. And that's how you find the vertex. You have 1 point for the parabola. You should make a parabola with 5, 7, 9 points. 5 points is ones we'll be doing, but the more points you put on, the more accurate your graph will be. So that's the vertex of it. Now, how are we going to calculate the other points? Well, let me bring that back for you. Let's start here at the x value of the vertex at 2. If we go up 1 to 3, we should also go down 1 to 1. So the distance from 1, I got to put down my eraser. The distance from 1 to 2 is the same distance as it is from 3 to 2. Those are going to be the same distances. This is 1 away. This is 1 away. Now we could also go on the next one. We could go 2 away to 4, or if we wanted to, we could have went 3 away to 5, or 4 away to 6. If we went 4 away to 6, just pay attention to this part here. If we went 4 away to 6, we would also have to go, let's say 2 plus 4 was 6. So then we would say 2 minus 4 is negative 2. And so those are, both of those numbers, 6 and negative 2, are 4 spaces away from the vertex. For this one here, I think we want to go with, we'll just go with 4. And if you notice, this is 2 spaces away, or a distance of 2 away from 4, and 0 is a distance of 2 away from 2. So we're trying to get an equal distance there from the vertex. And the reason for that is because, remember, if this is 1 away from the vertex, let's see, 2, 1, the distance that that 1 has is going to be the same distance that the 3 will have. Okay, these distances are going to be the same. This is 1 away from the axis of symmetry, and 3 is 1 away from the axis of symmetry. So therefore, this number here, the y value beside 1 should be the same as the y value beside 3. And that has everything to do with a parabola is symmetric on both sides of the axis of symmetry. And we're going to use that concept to save us a little bit of time in doing our calculations here. Okay, let's go ahead and say x is equal to 1. If x is equal to 1, that's the first point we're doing. We've had to plug it in there for x. So y is equal to 1 squared minus 4 times 1 plus 3. We substituted 1 in for x. 1 squared is 1. Negative 4 times 1 is going to be minus 4. And then we have a positive 3. 1 minus 4 is negative 3. And we add 3 to it. And negative 3 plus 3 is 0. So y is equal to 0. So when x is equal to 1, y is equal to 0. We can plug that into the table. And so since this is 1, 0, the value of the y beside the 3 will also be 0. So we can go ahead and put those in there like that. We don't have to do any calculations. We don't have to plug 3 in, because y is equal to 3 squared minus 4 times 3 plus 3. If you were to plug 3 in, you get 9 minus 12 plus 3. 9 minus 12 is negative 3 plus 3, and you're going to get 0. So just showing you that you can save some time here and understanding that a parabola is symmetric. It's like a mirror image on both sides of the axis of symmetry. On both sides of that axis of symmetry. All right, so then now if we're going to go 2 spaces away down here to where x is 0, and this one is also 2 spaces away down here where x is going to be 4, what's the y value is going to be? I always like using 0 because that's an easy number to multiply by. Makes things a lot simpler. So here we go. If x is going to be equal to 0, what's y going to be equal to? Well, that's going to be 0 squared minus 4 times 0 plus 3. 0 squared is 0. 4 times 0, 0. And we add 3. What's 0 minus 0 plus 3? It's going to be 3. And so now, since x is 0, y is going to be equal to 3. We plug that into our quick sketch of the graph. So what about when x is 4, y is also equal to 3? Because a parabola is symmetric about the axis of symmetry. So here we go. We have those 5 points. We have those 5 points. Let me get that off there for you. Let's go back here. Write those into our table. You probably already have this table written down. So this is where we're at, and now you're just going to graph those 5 points. you have a graph, I would suggest using graph paper to do this. That way your grid is equal. That way you get a nice looking graph. I guess I just usually always start with a vertex first. 2, -1. 2, -1 is right there. 1, 0, 3, 0. They're both 1 distance away from the axis of symmetry. And 0, 3. And 4, 3. Those are 2 spaces away from the axis of symmetry. And so if we look here, we want to graph that parabola. Remember, when it comes down here and touches the vertex, it is a round, smooth turn. It is not, it's not a meeting at that point. It just goes through the vertex smoothly. You should try and make it look that way. Make sure you put arrows on the ends of it. That way you know it extends forever in both directions. And it should look something like that. Take some practice on getting those to look that way. That's going to be your first quadratic function. Let's move on to this one here. It says graph y equals 2x squared minus 12x plus 19. Well, let's identify A as 2, B as -12, and C as 19. First step, find the x-coordinate of the vertex. X is equal to -b, so that's going to be -12 over top of 2a. 2 times 2. -12 makes a +12. 2 times 2 is 4. And we know 12 divided by 4 is 3. So the x value of the vertex is 3. What's the y value of the vertex going to be? Well, we substitute the x value of 3. Remember, this is x is equal to -3, and that is the axis of symmetry, the equation for the axis of symmetry. So since x is equal to 3, we're going to plug that into quadratic function there. 2 times x squared minus 12 times x plus 19. You can go ahead and simplify this. I think you should be able to do this in your head because you should know what 3 squared is, which is 9, and then 2 times 9 will give you 18. 12 times 3 is going to give you 36. And then we drop down to 19. 18 minus 36 is going to give us -18. And then -18 plus 19 will give us a +1. So y is equal to +1 when the x value is 3. So now the next step is to just go ahead and figure out some x values that you want to use. Go down 1, and then you go up 1, and then from the vertex you go down 2, and then from the vertex you go up 2. You're trying to make those equal distance apart from the vertex. So let's go ahead and do those calculations. I'm going to use x equals 1 first. So if x is equal to 1, what's y going to be equal to? 2 times 1 squared. coming from that quadratic function, minus 12 times 1 plus 19. X is equal to 1, that's why I'm plugging it in for x. That's why I'm substituting it in for x. Work this out. You know, 1 squared. 1 squared is going to be 1, and then 1 times 2 is 2. In the middle, negative 12 times 1 is negative 12, and then you drop down your 19. So now we have 2 minus 12, which is negative 10. And negative 10 plus 19 is going to be 9. So when x equals 1, y is equal to 9. And since 1 is 2 spaces away from 3, what else is 2 spaces away? 5. Parabolas are symmetric. So the 5 will also have a y value. When x is 5, y will be 9. Now let's do the next one. X equals 2. When x is equal to 2, what's y going to be equal to? 2 times x squared. We substitute in for x. And 12 times x plus 19. We know 2 squared is going to be 4, and 4 times 2 is 8. Minus 12 times 2 is 24, and plus 19. Work this out. 8 minus 24 will give you negative 16, and negative 16 plus 19 is 3. So when x is equal to 2, y is equal to 3. And since 2 is 1 away from the vertex of 3, 4 is also 1 away. So 4 will have a y value. When x is equal to 4, y will be 3. So you have your 5 points, and you can go ahead and graph these. And you can go ahead and graph these 5 points. The vertex is going to be 3, 1. 1, 2, 3, 3, 1. If we look, A is positive, so A should be opening upwards. The next one is 2, 3. 1, 2, 3. And the next one is 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is opening upwards. So remember to draw a round, smooth turn down there at the vertex. And your graph should look something like this. Okay, let's move on to one more. See if you can, one more. See if you can go ahead and try this one on your own. See if you can identify A, B, and C. This one's a little bit different because you should probably think of it as negative 3x squared. Standard form is ax squared plus bx plus c. Now, in the original, there's no x, but you should know that in order to get rid of the x, there's going to be a 0 in front of it. So see if you can go ahead and graph this parabola on your own. It's a matter of following those steps and coming up with the 5 points, and then going from there. I will work this one out fairly quickly for you and show you what the graph looks like, because I think the next two are going to have fractions, and I want to give you a little hint on how to do those. So try this one on your own. A is going to be negative 3, which means the graph opens down. B is 0, and C is going to be 5. So go ahead and do what you can here. First step is find the vertex. The vertex, x equals negative b over top of 2a, which is going to be 0 over, I'm putting the negative sign down here. And so it's negative 2 times negative 3, which is positive 6, which is just 0. So the x value is 0. What's the y value going to be? Since x is 0, we plug 0 in there. And we know that 0 squared is 0, and 3 times 0 is 0. So basically just have 0 plus 5, which is 5. So now we need to find the other values. From the vertex we go up 1, and then we go from the vertex up 2. From the vertex we go down 1 and down 2. So those are equally spaced apart from the vertex. Okay, I'm going to let x equal 1 first. So then therefore y is equal to negative 3 times 1 squared plus 5. 1 squared is 1 times negative 3, which is negative 3, plus 5. And negative 3 plus 5 will give you a 2. So when x is equal to 1, y is equal to 2. Since that is 1 away, negative 1 is also 1 away, so we'll have a value of 2 also. And the next one, x equals 2. When x is equal to 2, y is going to be equal to negative 3 times x squared. And we're going to say plus 5 after that. X squared, that would be 2 squared, which is 4. And 4 times negative 3 is going to be negative 12. Negative 12 plus 5 is going to give you a negative 7. So y will equal negative 7 when x is equal to 2. Since it is 2 away, negative 2 is also 2 away, so the y value for it will be negative 7. Let's go ahead and graph these. Go ahead and graph these, and let's see what we have here. The first one is going to be 0, 5, so that means we go 1, 2, 3, 4, 5, and we notice that was C. C was positive 5, which is the y-intercept. The next point is 1, 2, so that means to the right 1 and up 2. Symmetric would be negative 1, 2. And then we have 2, negative 7. That's to the right 2, and 1, 2, 3, 4, 5, 6, 7 down. And the symmetric across. Same distance from the axis of symmetry. So let's go ahead and graph this. I got a little squiggly there for a minute, but I think you get the idea. Remember, it's round and smooth at the top. It does not come to a point there at the vertex. So if we look, we have that parabola graphed. The vertex is 0, 5, and the axis of symmetry, x equals 0, because this vertical line goes through the x-axis at 0. That's the axis of symmetry. Notice this is 1 space away, 1 space away, 2 spaces away, 2 spaces away. It is symmetric. This one here has a fraction in it, so let's Let's go ahead and work with that one. We still identify A, B, and C. A is 1/2, B is 4, and C is 5. Step number 2 says find the x value of the vertex. So it's x is equal to negative b over top of 2a. Negative b over top of 2a, well, that's going to be negative 4, and 2 times 1/2. Well, if you have a half and you multiply it by 2, you're going to get 1. So the x value is negative 4. The y value says we have 1/2. Plug in x, negative 4, plus 4 times negative 4, and plus 5. So I've taken the quadratic function, and I've substituted x in for it. Negative 4 squared is going to be 16. 4 times negative 4 is negative 16. We add 5. Well, 1/2 times 16, well, half of 16 is going to be 8. And we have 8 minus 16 is negative 8 plus 5, and negative 8 plus 5 is going to be negative 3. So when x equals negative 4, y will equal negative 3. That will be your vertex. Negative 4, negative 3. You notice A is positive, so A should, or the parabola should open upwards. I'm going to erase this so we can figure out the rest of our points to make our parabola. For negative 4, watch this next step here for a moment. Watch this next step. If I go down 1, or I'm sorry, that would actually be going up 1. If I were to go, let's say, down 1 to negative 5, and I want to find that, remember, just watch this. Y is equal to, so if x equals negative 5, we're going to plug it in for x. Negative 5 squared is 25. And 4 times negative 5 is negative 20. And so we're working this out. Now, what's 1/2 of 25? 1/2 of 25 is not a good number to work with. It's a, we can change it to a decimal, or we can leave it as that improper fraction. So we have 25 halves. And then we have all these other numbers out here to work with. Let me show you a trick so that way you can get this done quickly without having to work with fractions. I'm not going to say every time you're going to be able to get away from fractions, but in this case, this little trick here will help you to get away from the fractions. Sometimes you do have to work with the fractions in solving for the vertex or one of the other points, but I can show you something here to help you to make it a little bit quicker for you. You see that denominator there, the denominator of 2. Well, you always want to pick numbers that are going to, that denominator of 2 will be able to go into evenly. So if we look, what about negative 2? Right? 2 goes into negative 2, negative 1 times. And then, so remember, if we went up 2 from the vertex to get to negative 2, we have to go down 2 from the vertex. So to go down 2 from the vertex, negative 4 minus 2 will give you a negative 6. And then this brings us 0. 0 is a good number to work with. So from the vertex, 0 was up 4, and then from the vertex, we have to go down 4. So negative 4 minus 4 is going to be negative 8. So all of these are actually, when we did this, if we look, they're all, equally spaced apart. They go up by 2 every time. And you notice they go up by 2 every time. So let's go ahead and work this out then. X equals negative 2. I like working with smaller numbers. So if x equals negative 2, what's y going to be equal to? 1/2 of negative 2 squared plus 4 times negative 2 plus 5. I just substituted negative 2 in there for x. Negative 2 squared is going to give us, negative 2 times negative 2 is going to give us a positive 4. 4 times negative 2 is a negative 8, and then we have the 5. What's 1/2 of 4? 1/2 of 4 is 2 minus 8 plus 5. 2 minus 8 is negative 6 plus 5, and negative 6 plus 5 is going to give you a negative 1. So when x is equal to negative 2, y is equal to negative 1. And since that is 2 away from the vertex, 6 is also 2 away from the vertex, it's also a negative 1. I'm erasing this, so if you need this up, go ahead and pause the video. And now let's look at when x is 0. That should be an easy one to do, because 1/2 0 squared, 4 times 0 plus 5. 0 squared is going to be 0, and then 0 times 1/2 is going to be 0. 4 times 0 is 0, and you add 5 to that. 0 plus 5 is going to be 5. Since 0 is 4 away from the vertex, 8 is also 4 away. I'm sorry, that was negative 8 is also 4 away. So it will have a y value of 5 also. So that we can go ahead and graph these. 5 points. Let's see, 5. Oh. 5, negative 1, negative 3, negative 1, 5, and here's the x values. Remember, a is positive, so this will open up, and let's go ahead and graph those points. The vertex is negative 4, 3. It's 4 to the left. Oh, negative 4, negative 3. 4 to the left and 3 down. Then we have negative 2, negative 1. And 0, 5. 1, 2, 3, 4, 5. And this is our vertex right here at the bottom. Remember, you're supposed to go a round, smooth curve through that vertex. Put arrows on the ends of it. And you have your graph. The axis of symmetry equation, x equals negative 4, is right here. That's your axis of symmetry. You do not have to have the axis of symmetry on your graphs. This is just something extra I'm showing you. And we notice that this is 2 away. That point is also 2 away. We notice this point is 4 away, and this point here is 4 away. Right here is your y-intercept, and that was letter C, your y-intercept. Take a real quick look here. You're supposed to notice A is 1/2. Look at the graph. Look how wide the graph is for you. Now come down here and look at A is -3. Look at how thin the graph is. And when A is 2, it is not quite as thin as when A was 3, but it's still not as wide as when A was 1/2. So the larger the number for A, pay attention to this, when A is larger, the parabola gets thinner. When A is smaller, when A goes to become smaller, then the graph becomes wider. And if you pay attention, let's say right here, A is 1/2. And now in this next example, we're going to look at it. A is going to be, I think, 1/3. Yeah, A will be 1/3. It's negative. That just means it opens down. But A will still be 1/3, which means that it should be a little bit wider than the last graph that we did. B is going to be 1, and what's C in this case? There is no C because it just says +0 out there. We don't need to say +0. You should notice that it's nothing out there. Okay. If you want to work this one out on your own, go ahead. If you want to work this one out with me, since it has a fraction, and I'll help you out with that trick again on how to get the y values to be easy numbers to manage, or easier numbers to manage than fractions. You can follow along with me. First step is to find the vertex. So it's going to be -1 over top of 2a times -1/3. All right, so we're looking here. We are looking at what is 2 times -1/3? Well, that's 2 over 1 times -1/3. You just multiply the number straight across. So 2 times 1 is 2. 1 times 3 is 3. +2 times -1/3 will give you a negative. And so far we know that a negative divided by a negative is going to be a positive. And when we have fractions that we are dividing, we multiply by the reciprocal. So on top we have 1. On bottom we have 2/3. The reciprocal of 2/3 is 3/2. So multiply those. Straight across you get 3/2. And like we said before, a negative divided by a negative will give you a positive. So the x value of the vertex is going to be 3/2. Now the y value here, the y value, y is equal to -1/3 x squared plus x. Okay, well, first off, let's go 3/2 squared, so that's 3/2 times 3/2. Top numbers multiplied will give you 9. Bottom numbers multiplied will give you 4. So we have -1/3 times 9 over 4 plus 3/2. I'm looking to multiply -1/3 times 9 over 4. Well, I know 3 goes into 3 once, and 3 goes into 9 3 times. So I can reduce those. That's a number on top with a number on bottom. So multiply straight across. 1 times 3 is 3, and 1 times 4 is 4. We had negative times a positive, which will give us a negative. And since the denominator here is 3/4, I'm going to go ahead and change this denominator. How do I change 3/2 so that it has a denominator of 4? Well, I multiply that bottom number 2 by 2 to get 4. So then I got to multiply 3 by 2 to get 6. I'm just changing that right now so that way I have common denominators and I can add those together. So if we have negative 3/4 plus 6/4, that should be a positive. Negative 3 plus 6 is positive 3. We have 4 on the bottom. 3/4. So we have the vertex. Not a real fun vertex to graph, but we can graph it nonetheless. I'm erasing all this work here so that way we can work out some of the other values. All right, before, from the vertex, when we were trying to find the other x values, we would always go up 1. But if we went up 1, that would put us at 5/2. Or some of you might think 2.5. But 5/2 is what I would be thinking. I don't want to do that, because then that's another fraction that we have to work with in our calculations. So let's go up to plus, let's add 1/2 to that. So if we say 3/2 plus 1/2, that's going to be 4/2, which is equal to 2. Well, if we added 1/2, we should subtract 1/2 to get to that one. So let's say 3/2 minus 1/2, which is going to be 2/2, which is 1. So there's that one. So I know that's not what we were used to doing, because we always went out by 1s, it seemed like. Or in the one example, we went up by, last example, we went up by 2s. But here's the thing. We still went up and down by 1/2. Okay? And so we can do that. We can put a 1 there, we can put a 2 there, and we can still find the y value. That the values are still the same distance from the vertex. Now here's the thing. You can go ahead and do that and plug it in. You can plug them in and work them out right here. Figure out what the solutions are. You're probably going to get some fractions. Like I told you before, I'm not real interested in having fractions because they're not real easy to graph. So let me think here. Let's go back to what I told you in the last one. The denominator was 3. The denominator was 3. So we need multiples of 3. Well, what are you thinking? Well, I'm thinking 3 is a multiple of 3, right? So how far away from the vertex of 3/2 is 3? Well, we know 3/2 is approximately 1/2, so 1.5. So what number do we need to add to it to get 3? I don't want to use x. Let me use, just put a question mark there. Well, what number does the question mark have to be? Well, the question mark has to be 1.5, right, or 1.5. 1.5 plus 1.5 is equal to 3. So this was up 1.5. So we should also go down 1.5. And down 1.5. Well, 3/2 is equal to 1.5. So if we say 3/2 minus 1.5, we're going to get 0. And that's a good number to work with, right? 0's lovely to work with. Okay, So now let's find our next multiple of 3. Well, our next multiple of 3 after 3 would be 6. Well, what do we have to do here? Well, from here to here, we added, what do we add? From 1.5 to 6, so 6 minus 1.5. What's that give you? 6 minus 1 is 5, and then 5 minus a half is 4.5. So we added 4.5. So here you should, if you add 4.5 to get from the vertex, what should you have to do to find that x value there? You should subtract 4.5. So if we're going to have the vertex is 3.5, right? Or I'm sorry, 3 halves, which is 1 and 1/2, and you minus 4 and 1/2 from it. All right, so let's think about this here. 1 and 1/2 minus 4 and 1/2. So 1 and 1/2, let's just do minus 1/2. 1 and 1/2 minus a half is going to give you 1. And so now we're left with 1 minus 4, which is negative 3. Negative 3. And we can check this. I've always told you to check and make sure that the distance from the vertex is the same, right? Minus 3.5 and plus 3.5. Those distances are the same. Well, if those distances are the same, and the distance from, let me show you here, and the distance from these two are the same, because from 0 to negative 3 would be minus 3, and from 3 to 6, that would be plus 3. So these distances are the same, and these distances are the same. So therefore, the distance from the vertex to there must be the same as the distance from the vertex to negative 3. Might have been a little confusing, but once you start working with these problems and you start seeing this in your head and you start understanding and practicing this, instead of saying, hey, this just looks hard, and not do it, you, if you were to practice this and try this, it would come to you. This comes easy once you practice it, but you have to practice it. If you totally avoid it, it's not going to work. I know I'm completely trying to avoid fractions in this problem, but this is the one part of math that I do try and avoid fractions, for the simple fact that when we graph, I like whole numbers to graph. That way our graphs can be, exact, and they can look neat. So that whole thing of trying to find those x values, I know it took a little while for me to explain that, and it may take a little more in-person explanation for you to understand, but with practice, you'll be able to figure that out in your head a lot quicker than what I explained it to you, and then you should be able to go from there and make things a lot smoother process. Should go a lot faster. So let's look here. I'm just going to let x equal 0 because I like working with 0. Y is going to be equal to negative 1/3 x squared plus x. And we know 0 squared is 0, and 0 times negative 1/3 is going to be 0, plus 0, which is 0. And we probably should have known that because, well, c is 0, so right there is the y-intercept. All right, now you can pick another value. Well, if x is 0, y is then 0. If x is 3, y is also 0. The other value I'm going to pick, doesn't matter which value we pick here. So let's say x is equal to negative 3, y is equal to negative 1/3 times x squared plus x. X was negative 3. So what we're going to have is negative 3 squared is 9. Negative 1/3 times 9 over 1. Well, we know that 3 goes into 3 once, so we cross it off and put a 1, and 3 goes into 9 3 times, so we cross it off and put a 3. Multiply straight across. 1 times 3 is 3, and on the bottom, 1 times 1 is 1. But really, what's 3 over 1 equal to? It is equal to 3. Now we kind of got ahead of ourselves. We got to look at the signs up there. It was negative 1/3 times positive 9. So negative times a positive is a negative. And then minus 3. So negative 3 minus 3 is going to be negative 6. So when x is negative 3, y is negative 6. And then down there at the bottom, when x is 6, y is negative 6. So this is where we're at. And then you have 5 points that you can graph. Let me go ahead and write these down. There you go. That looks better. So let's go ahead and graph these. The vertex is really the one that's the most difficult to graph. It's 3/2, 3/4. So 3/2 is like 1 1/2, and 3/4 is kind of like just above a half but below a whole. So it's that little point right there. 3/2, 3/4. The next point is the origin, which is 0 0 and 3 0. And then we also have negative 3, negative 6. So it means to the left 3, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. And then we have 6, negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there's what the graph should look like. Make a round, smooth curve at the vertex. And this is the graph of y equals negative 1/3 x squared plus x. Now let's look at the graph of this compared to the graph of the one before, which had a was 1/2. In this case, a is negative 1/3. So let's look at the 1/2 and the 1/3 part. Here's the graph here, and there's the graph before. If you notice, it looks like this one is slightly, just a little bit larger, a little bit wider than the other one. So it's just a little bit wider. You're not going to see much of a difference with these values that are so close. When you start working with really small numbers like 1/10 for A, then you would notice a great difference. So this is graphing quadratic functions. It's a tedious task. You've got to pay attention to all your signs and pay attention to your calculations. Make sure you get all those right. If you have any questions, I will see you soon.